Grade 11, choice 2, first half hour. Action.
Thank you. Okay, now we're about 60,000 slides behind the other class, which I've decided is the clever class, and you're the Dorfies.
No, there's 2 in that class.
Now, there were 4 today. I have to say this, at least you guys are braver than the other class.
Yes, ma'am. And they're bigger than
But I can't say that out loud because apparently somebody watched a choice 2 thing the other day. So I've got to be very circumspect.
Haley, what did it take? Did she
Okay.
get 26 jokes? Yes.
Did she what?
No!
26.
No, 26 seconds, sure, man. Like that.
Okay, moving on. Okay. Right. So we got as far yesterday, being the slow class and all, as the meninges. Okay? So remember that the meninges are 3 membranes which surround the brain and the spinal cord. Okay? And they're continuous around the brain and the spinal cord. There's no cut-off point there. And they, from the outside inwards, are the Gr11, mater, which is the very, very tough one. And the Gr11 mater lies right underneath the cranium, and it actually connects with the periosteum of the cranium. Those two are fused together and form what appears to be one membrane. Okay, so that's the Gr11 mater. Directly underneath that is a much more spider web-like membrane, which is called the arachnoid or the arachnoid mater. And you can remember that because you can remember that spiders belong to the class Arachnida. Are we getting comprehension going here? Are we sure we know about Arachnida?
Yeah.
Okay. Yes. Yes. Okay. So this membrane, because it's quite web-like, is called the arachnoid or the arachnoid mater. I'm fine if you just call it the arachnoid. And then there's a space. And then the inside membrane is called the Pia Mater, P-I-A. Now, all of these are lowercase. Okay? So this is a US drawing. And that's why they don't have the difference between lowercase and uppercase and when to use them correctly. And so these are all written with uppercase, but in fact they should be written with lowercase. Okay.
Are these the membranes surrounding the brain? Those, is that like a diagram of what it is? Like you see those blocks?
Yes.
Is that what it looks like?
Well, not really as blocks. This is just a block.
Yeah, like a
Yeah.
cut. Into
Yeah. So it would be if you cut through those membranes, then the outer one is the Gr11 mater and it's attached to the periosteum. Directly underneath that is the arachnoid. Then there's a space, and then there's the inner one is the Pia Mater. And the Pia Mater actually lies right on the surface of the brain and spinal cord. So the other ones don't really go in with the fissures of the brain. But the Pia Mater goes in the little crevices and the fissures and whatever. It's very
like
close.
vacuum packed.
It's almost stuck on. Not totally non-removable, but it's stuck onto the surface of the brain.
In this space, is there like fluid or is it just?
Yes, we're going to talk about that. Okay, you're okay with the 3 membranes? Can you read the names? Do you need me to write them? No? Good thing, because you know I write badly. Okay, right, so arachnoid, Gr11 mater, arachnoid, space, Pia Mater. And you can remember that the Gr11 mater is the outer one, the tough one, because for me the connection is durable. If something is durable, it's tougher. Look at these faces. Got Tony looking at a nail. The rest of you all going, what is this woman talking about? Okay. So Gr11 mater, the tough one, durable. Okay, arachnoid, spinal webby one, and then the space, and then the Pia Mater. Now you will see that the blood vessels run on the surface of the Pia Mater. Okay, now in this space here, there is fluid, and it's a kind of tissue fluid. You remember you learned about tissue fluid last year? You learned that blood plasma is able to leak. In fact, you learned about it in nutrition as well this year. Blood plasma is able to leak out of blood vessels, and it flows between the cells, and that becomes called tissue fluid. And most of the tissue fluid goes back into the blood vessels and becomes blood plasma again. Not all of it does. Okay, so this tissue fluid that is found in the space between the arachnoid and the Pia Mater has got a very special name. It is called Cerebral.
Remember, this is the fluid. The space. Oh, the space.
No, the fluid, you nanas. Do you not listen to anything I say?
You heard it. I know. I know. It's silent. I was like, what? I'm gonna run again.
Okay, cerebrospinal fluid. And that's because it's continuous around the brain, which is cerebral. If you're talking about, like kidneys are renal, lungs is pulmonary, heart is cardiac, brain is cerebral. Okay, so cerebrospinal fluid. Because the fluid is continuous around the brain and around the spinal cord. So if I injected a red dye into the cerebrospinal fluid up here, and then I took some cerebrospinal fluid out down there, it would be red.
When does it move, or does it just kind of diffuse?
No,
Does it just diffuse in and keep going in, or what is it?
Yeah, so we'll talk about the movement just now, but just realize that it's continuous. Okay, you happy with that? And that is why doctors are able to do something called a lumbar puncture to establish whether there's something, an infection or bleeding on the brain. Okay, now obviously Tony knows about a lumbar puncture because I heard that scream of agony going there.
Have you had that? No, Jenna came with everywhere. She had one, and I remember her telling me about it, and she described it in such vivid detail that English teachers would be so proud. But the way she did it, it was like, oh.
Okay, so the whole thing about a lumbar puncture is, because that fluid is continuous, if there's something wrong with the brain, like inflammation of the brain or bleeding on the brain, they don't want to drill a hole through the skull and take some fluid out there, because then now it's a big hole in the skull. Okay. So what they do is they take it out. Are you allowed to say the word spine in my class?
Spinal vertebral column.
Vertebral column or spinal cord, but not a combination of the two.
I said spinal cord.
No, you said spine. I'm not that deaf.
I corrected it. It's spinal cord.
Good, I'm proud of you. Okay, so remember that the spinal cord runs down the center of the vertebral column. And remember that the vertebral bones are individual bones and there are little spaces between them. So if they do a lumbar puncture, what they do is they take a patient and they put the patient lying on their side, curled up in a fetal position. In other words, what they're doing is they're making as big a possible space between the vertebral bones of back. Okay? And then without an anesthetic, they insert a syringe, a needle of a syringe, through the back, in between these bones, where the bones have separated like that, through the dura mater, through the arachnoid, into that little space. And they aspirate some of the cerebrospinal fluid.
How did they reach the space?
I would imagine they now do a scan thing.
Isn't that the same as an epidural? Doesn't it also go in your back?
Yes.
Like
Not my back.
And is that like when they inject you for a
When you're pregnant.
Yeah. So then they take out some of that fluid and they're able to do tests on it. So they're able to see things like, is there bleeding in the brain? If a person has meningitis, they can then test, is it viral meningitis or is it bacterial meningitis? If they've got encephalitis, they can do various tests, etc. The only issue is that they don't give an anaesthetic, because they need to monitor the person's responses to make sure that they haven't gone too far and like made them paralyzed.
Then how does the epidural work if you have like a baby? If someone has a baby?
It goes into your
Good.
like,
Yeah, it goes the same
I
thing.
do the fetus and the
when I went to it, my mom, for my job shadowing, I was job shadowing, and like the lady has to sit down, and then after, like the anesthesiast, like she'll come and then she'll like put the epidural like in the spine, and then she'll have to bend over.
In the what?
Spinal cord. And then she has to lean forward, but like just enough so then she doesn't like hurt herself. And then there's just, it's
a long needle, isn't it? Isn't it this
It's like-
long?
I think he's so scared that something goes wrong that he just stands
Does
still.
it go like this or does it go like
it
this?
goes like up into.
But how do people keep, like, how do they just stay still? Like,
Don't they jump?
I think he just has.
I think
Yeah.
they really get like pills. If you like get nervous, then they give you something to calm you
Yeah.
down, and then you won't have to think about it as much.
Because if you don't have that, it will die of pain.
Yeah, some people have that.
Okay. The moral of the story is contraception. There be no hanky-panky.
So easily wrap it with you.
So like it's the membrane, so they continuous. So they go like this around the brain and
Yes.
then still around the whole
Yes.
spinal cord.
Yes,
So like a continuous thing
Yes.
the whole way down.
yes,
And then fluid also in the spinal cord.
yes.
Okay.
But then how would they be able to tell that there's bleeding? Like,
So if they take fluid out here and check that fluid and there's blood in it, which there shouldn't be,
The blood goes everywhere.
then they would know that there's
okay.
bleeding
Then how
out
would
there.
they be able to like locate where it is, whether it's
They would be suspecting that there's something going on in the brain. Okay.
Man, is the thickness of that little, of the cerebral nerves, or cerebrospinal fluid, is it the same thickness of that gap throughout the whole?
I'm not certain. I don't.
So it can't just be like thick and then like thin.
And then the needle goes,
Yeah, like and then
no, I would imagine it's the same thickness. Okay, you okay with that, guys? So there we go. Gr11 mater is the tough outer membrane. It lines the inside of the skull and the vertebrae, and it protects the outside. And remember, you're not allowed to do what I've just done. You're not allowed to say it protects, because then I don't know what you mean by that. So you've got to say it protects it from mechanical damage or whatever. And it keeps the brain firmly attached to the inside of the skull, so that it doesn't flop around that easily, especially if the brain is much smaller than the cranium.
Pew, 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 pew.
I never said that. Okay, I've now jumped from the outer to the inner. Okay, so the Pia Mater is the inner one that is in direct contact with the brain tissue, and it helps to supply the cells of the brain with food, nutrients, and oxygen. And that's because the Pia Mater has these blood vessels lying on top of it. Okay. And then the arachnoid lies between the dura and the Pia Mater and contains many blood vessels running through it and provides the brain and spinal cord with nutrients and oxygen. So if you look here, if you look at the surface of the brain, you can see that the surface of the brain has got these blood vessels lying on it. Okay.
The blood vessels are in the little Pia Mater.
Yeah. Above the Pia Mater, more associated with the arachnoid mater. So if the meninges are peeled off, as you can see here, you can see that the blood vessels go with it. Okay, right, so those blood vessels are not actually in the brain. They're on the surface of the brain, as part of those membranes. Okay, so working from the outside inwards, if you took a little block out of the skull, okay, skin, all of you know that there's skin on top of the skull. Periosteum, which you learned last year, is the membrane that surrounds the brain. Then there's bone, dura mater, arachnoid, Pia Mater, and then either the brain or the spinal cord, depending on what you're looking at. And then the gap is between the Pia Mater and the arachnoid. Okay.
Now, some people's brains are actually bigger and smaller. Not associated with like intelligence, but like they actually could be smaller or larger.
I do think that they are.
Like,
But there's also to do with, and I could be lying, I could very well be lying, but I have a memory in my head which tells me that Einstein's brain had more fissures and folds than normal. And apparently that's an intelligence link thing. I don't know, I could be lying.
So like if your brain is smooth, like you see it on.
Yes. And that's an issue with when we get to, I've put in a little section here that you need to remember for grade 12 called fetal alcohol syndrome or fetal alcohol spectrum disorder. And that's to do with if a mother drinks alcohol while pregnant.
Damages the brain.
It does a whole lot of things. It depends on when it happens, how much alcohol, and a whole lot of other associated things. And I'll show you a picture of a brain taken from a child who died, obviously, not because of the alcohol, but who in fact died, and they took the brain and they took photographs of the brain, and it's very smooth. It's very
So it's
smooth.
actually like
Oh,
damages.
hugely. I've got amazing pictures. It's one of
That
the
is so fancy.
Yeah, I'm telling you, you will never drink when you're pregnant if you see the stuff that it does.
Always don't get pregnant, you know.
I tried saying that was a good option, but you all just went,
Now, does smoking when you're pregnant do the same, or does it usually
no, smoking does other things. Okay, all right. So this then as well is obviously looking down from the top of the head, having used a chainsaw to cut away the top of the cranium so you can see the person's pinny there. And so, yeah, you can see the meninges here as well. Okay.
Is that real?
They're real.
Yeah.
A person?
Yeah.
A dead person?
Why is it so like neat?
It's like marble.
Okay, all right. So what are the functions of the meninges and the cerebrospinal fluid? Primary functions of the meninges, together with the cerebrospinal fluid which circulates between them, is to protect from mechanical damage to a certain extent. Obviously not as much as the cranium does, because the cranium's hard, but to a certain extent, to support the brain, but terribly, terribly important, to nourish the brain and spinal cord. In other words, because it contains the blood vessels, oxygen and nutrients will diffuse from the blood vessels into the cerebrospinal fluid and into the brain or the spinal cord, and carbon dioxide and waste will diffuse in the other direction and be taken away by means of those blood vessels. Okay, so that's the importance of that. All right, now you need to listen carefully to understand this. Just ignore these pictures in the meantime. There are 4 cavities in the brain filled with cerebrospinal fluid. So not only is there cerebrospinal fluid in between the Pia Mater and the arachnoid, but there's also cerebrospinal fluid within the brain. And that cerebrospinal fluid is found in 4 little cavities in the brain. And those cavities are called ventricles, just like last year we learned about ventricles in the heart. Absolutely. Okay, so now picture the brain. Okay. The first and the second cavity, also called the lateral ventricles. So the first and the second ventricle, or lateral ventricles, don't obsess about this, are cavities inside here and here. So if you took a section through the brain, you would not be able to see them if your section went through the middle, because they're on either side. They have got a tiny little channel which runs towards the center from each of those ventricles, and the third ventricle is in the middle, and that connects via a little canal to the 4th ventricle, which is further down in the back of the brain, and that connects via what is called the central canal to the central canal in the spinal cord. So it actually carries on all the way down the middle of the spinal cord, right down to the bottom of the spinal cord. Okay, so ventricle 1, ventricle 2, inside the brain. Ventricle 3 is in the middle. Ventricle 1 and 2 and 3 are connected by a little canal. Okay, then a little canal to number 4, which is closer to the back, and then the central canal, which runs all the way down. So there's ventricle 3. Okay, you obviously can't see 1 and 2 in this section. Does that make sense? Because it's deep inside here. There's ventricle 3, and ventricle 4 is down here, down upstairs. Okay, they're not little. I said it. See Erin's eyes going, she said it. Even though she said she wasn't ever going to say it again. Okay, so they're not as simple as little round holes inside the brain. They're actually, this is the 2 lateral ones. There's the 3rd one, there's the 4th one, there's the central canal which carries down the spinal cord. Please don't go and learn this. Okay. Which is my new saying, I don't say it, I'm obsessed anymore. Okay, right, don't go and learn it. But they connect to each other and they also fill the cerebrospinal fluid. Okay, right, happy, happy. Okay. Right. The regions of the brain. So there's no real defining, here's the border, but basically it goes, each side of the brain is divided into 3 different parts called the forebrain, the midbrain, and the hindbrain. Okay, so here in brown, that's all forebrain, and you can see it's much bigger than the other 2 parts. The midbrain is this little green part in the middle here, and the hindbrain is all this part here, and that extends into the spinal cord. Now you don't have to know this, but I think it helps to understand this, and it goes like this. If you consider that humans have evolved as bipedal organisms. Okay, what does that mean? It means that they walk on 2 legs and they walk upright like that. Okay, if you consider all the other animals before that, like for example, a crocodile, okay, then realize that this whole setup is going to be different. So if you consider a crocodile, for example, okay, so...
Oh, I know what you're saying now. The hindbrain would be in a different place.
Absolutely.
Because it's connected to the spine. Spinal cord.
Taught a child one thing in my lifetime. Okay. Alright, so here's a crocodile. Good one. Considering my normal skills of drawing. Okay. Then, in fact, the brain is spread out differently. So this would be the forebrain, that would be the midbrain, that would be the hindbrain, and that would be the spinal cord. But what has happened with humans becoming bipedal is that everything is now like that, and those 3 parts are... Oh, you don't have to, Mr. Ruzmiza just cuts it into 2, but you can go end of the first half hour.
End of the first half hour.
You don't have to stop.